All right. Hi, it's me again. I'm still with homework 4. Sorry about that, except I'm doing problem number 2. Again, this is Judy Mizraki. Okay, and problem number 2 is kind of a cute one. Basically it says to draw y equals g of x correctly and then find fy of y, f and little fy of y in terms of big F x of y and little f x of y. Okay, so this is easy. And our parameters are given. I'm going to go ahead and write them out and we can start there. Okay, fine. So we know y equals g of x. Can you see this? Yeah, good. Which is equal to, let's see, 1 for x less than 0, 0 for 0 less than or equal to x less than 1, negative x for 1 less than or equal to x less than or equal to 2. Okay. I'm guessing this is supposed to be a less than, oh yeah, that's right. Or negative 2 for x greater than 2. Okay, is that right? Yes, it's right. Awesome. So, the first thing we should do, of course, is draw y, just to give us kind of an idea of where we're holding. Okay, so it says that y is 1 for x less than 0. So this will be x, this will be g of x, which is y. So this will be 1. Okay, so we have whoop, awesome. It's equal to 0 between 0 and 1, so whoop, we're going to have that line there. So we'll just like kind of dot this here and then whoop. Okay, good. Following, awesome. And then it's equal to, one sec, did I skip something? No, I think we're good. Negative x between 1 and 2. Okay, so here's 2, here's 1, and here's 2. So since it's negative, we're going to have negative 1, negative 2. It's going to look like this, whoop. And then of course it equals negative 2 all the way rest, okay? So we'll have something like that. Okay, awesome. This is kind of a classic example, and it's pretty easy to know what to do. It's pretty obvious, right, that we're doing f of x, so let's start with that. F of y. So we'll start with big Fy of y, and that's just the probability, okay, that my y, my big Y, is going to be less than or equal to like any y chosen, okay? Well, I know that as long as I choose a y bigger than 1, I know that I'm 100% going to be above my curve, okay? So I can say that this is equal to 1 when y is greater than or equal to 1. Okay, awesome. What else can I say? I can say that it's equal to 0, okay, when y is less than negative 2, right? Because if I choose it, if I choose my y down here, there's no way that any of this curve is below that, okay? So now we have two regions that I want to know about. I want to know the region between y equals negative 1 and y equals 1, right? Because I didn't deal with that yet, and I didn't deal with the area between y equals negative 2 and negative 1, okay? Because see how those curves kind of change. So let's go ahead and start with this one, because that seems like a pretty easy region to deal with, okay? Well, let's start over here. So for negative 1, less than or equal to y less than 1, okay, we notice that my big Y is going to be 0. Okay, fine. So what does that tell us about big F? Well, obviously then we're really looking for, like, big Fy of y is the same thing as the probability that 0 is less than or equal to y, okay? And at this point, we're kind of like, oh, dang it, because I want f sub x, and now I have f sub 0. So there's probably other ways of doing this, but I kind of just noticed, can you still see this, that 0 is equal to x minus x, and 0 less than or equal to y is the same thing as saying x less than or equal to y plus x. See how that works? Because if I subtract that, I get 0 on both sides. So I can change this to p of that x is less than or equal to y plus x, okay, which is the same thing as f sub x of y plus x, okay, and so this is what it's going to equal. So then I have f sub x of y plus x for negative 1 less than or equal to y less than 1. This is pretty simple. You following that? Okay, cool. Now, of course, I'm almost done. I've just got one more region left to worry about. So now I want the region of negative 2, right, less than or equal to y less than negative 1, this area right here. Well, in that area, I know, of course, that y is just equal to negative x, right? It's defined that way. So that means that the probability that y is less than or equal to y. It's the same thing as the probability that negative x is less than or equal to y, which of course is the same thing as the probability that x is greater than y, negative y, excuse me. And now we're in trouble, right? Because it's like we want to use big F, and that is a less than or equal to symbol, not a greater than symbol. Well, of course, this is just the same thing as 1 minus the probability that x is less than or equal to y, which is the same thing as 1 minus big F sub x of y. All right? Awesome. Oh, this is negative y, negative y. All right. So with that, we're done. So then we have 1 minus big F of x of negative y for negative 2 less than or equal to y less than 1. All right, and you'll notice now we have the entire graph defined. F of y, big F of y is defined everywhere in terms of f of x. Can you see that still? Okay, good. Awesome. Great. So there's a few ways to go ahead and start writing your little f. You can just go ahead and directly differentiate. I personally like to use the unit step function, so I'm going to go ahead and do that, okay? Looking at this, we know right away that if y is bigger than 1, we have a value, right? We have 1, so we have to put in something for that. So we can, of course, use the unit step function of y minus 1, right? Because that way, anywhere bigger than 1, you're going to get, we're going to get a 1 value in there. So we have our 1 for f of y, okay? Well, this is what our f big Y of y equals, okay? This, okay, plus, now we're going to, this part we can kind of ignore because it's a 0 value. We're going to go on and move on to this one. Okay, well this one tells us that we have f sub x of y plus x, okay, at the unit step function, sorry, my bad handwriting, it's a little late at night, y plus 1, right, because that would give me 0 for negative 1, plus, one second, make sure I'm doing this right here. No, this should be minus because it's an interval. I'm sorry about that. Minus the unit step function of y minus 1. Okay, awesome. Okay, and now we finally have one more to take care of. So this really isn't so bad. It's kind of a fun little thing. Minus f sub x of negative y. And of course, this is my unit step function from negative 2, excuse me, to positive 1. Should that be? This should be a negative 1. So unit step function of y plus 1. Did I do this right? Hang on a second. Minus. So this is a plus, this is a minus, that's right. And then this. What did I do wrong? I think it is. Oh, I'm sorry about that. Yes, this should be a minus, and this should be a plus, right? Because I'm going from negative 1 to 1. One second. This is negative 1, so I'm going from negative 2 to negative 1, so this is plus. I'm going from negative 1, so this should be a plus, to, sorry about that, to positive 1, so this should be a minus. Sorry about that. Okay, good. It's like 3 o'clock in the morning, so I'm kind of a little loopy, okay? But that makes sense. I'm sure you'll forgive that. It's good because this way I had some extra time to look everything over. And this should be my full equation, I believe, unless if I made a mistake. I'm just going to take a minute, and you should too, to just kind of look this over and make sure that it makes sense and that we're happy with it before we move forward. I think I am. So this will be this. Okay, beautiful. We're almost done. Now, what about my little f? Well, that's simple. All I do is I differentiate. So I have my little y of y is equal to, the derivative of this, of course, is my delta function, y minus 1. Okay, beautiful. I have to take use the chain rule, so I have to take the first and the product rule, excuse me, and then the second, plus the second minus the plus times the third. So that's going to be plus f sub x of y plus x times this, so this will be, excuse me, you know what, I'm going to actually go ahead and, I'm going to just pull this down because it's a little bit messy. Alright, so we're going to do it down here, okay? So I have f sub y of y, sorry, big Y of y, can you see that? Awesome, is equal to delta function of y minus 1 plus fx of y plus x times delta function of y plus 1 minus delta function. I know this is technically bad notation, but I'm going to fix it up in a second, okay? Y minus 1, because technically we have different y's defined here, so we can make it simpler a little bit later. And then, okay, plus, now of course we have to take the derivative of the second times the first, so that's going to be derivative of the inside times just 1, so we have fx of y plus x times unit step function y plus 1 minus unit step function of y minus 1. Beautiful. Okay, good. Almost done. Plus, again, similar process, negative 1 times, we're going to delta function this, delta function y plus 2 minus delta function of y plus 1. Okay, good. And then, of course, this. So we're going to have plus, derivative is 0, this is negative, but then we pull out a negative, right? So we get little fx, excuse me, little fx is negative y. Okay, good. That should be right. One second, just double check. Yes, this is right. Little fx of negative y. And of course, this is times my unit step functions. I'm sorry if I made a mistake here arithmetically, but you kind of get the general idea. And of course, I'm going to go ahead and simplify this. The way that I'm going to do that is by grouping my delta functions, right? Because at these delta functions, I can substitute for the y here would be negative 1, the y here would be positive 1, and so on and so forth. So I'm going to go ahead and do that. So here I'm going to, first of all, group together all my y minus 1s, my delta y minus 1s. I think that's it. Okay, good. So then I just get del y minus 1 of 1 plus fx y plus x. Okay, good. And of course here, since my delta function is only defined at a singular point, in this case it's going to be 1, this becomes 1. Okay, good. Now we'll take, I'm just going to go ahead and cross off so I don't lose track. I'm going to take y plus 1, so plus the delta function of y plus 1 times, again, this time it's going to be defined at negative 1, so we'll just say x minus 1. Let's see, where's it? Y plus 1? Oh, this is a nice one. So then we have plus 1 minus fx of negative y. Okay. And again, this negative y is just negative 1, so it becomes 1. Beautiful. So we got that. I think that's it, yes. Plus my delta function. You find a delta function here. We've got one more delta function, I think, to deal with. So this is taken care of. Yes, this one. Plus delta function of y plus 2. And of course, this is going to be defined. Can you still see that? Good. At, so 1 minus f sub x of 2. Beautiful. Okay, so we're just going to draw lines so you know which equation I'm working with here. So then this is gone, and now I just fill out everything else, right? So I'm going to go ahead and sort by my u's, because that, again, is kind of good notation. So I really should have done this before with my big f of x, but you get the idea. Y, let's see, we'll use y plus 1 first, times fx of y plus x plus f sub x of negative y. Is that right? Yes. Or no, this is a minus, I'm sorry. See if that's right. Let's see, f of x of y plus x, that's right. Minus, yes, okay, good. Awesome. And then we have this plus u, I'm sorry, minus u, excuse me, of y minus 1 times big fx y plus big x plus u of y plus 2 times f of negative y. And this is our answer. Now, obviously, there's ways to simplify this and make it a little bit less messy, but this is the idea. All right, thank you. I hope you enjoyed. Take care. Have a good night.